Dear all, welcome to the course Signals and System Unit 1 Session 9. Now in this session we are going to study the second half of the first unit, that is system. Okay. So first of all we will define the system. A system is a set of element or functional block connected together that processes and manipulate the applied input signal to accomplish a required function and producing the new signal at the output. This is the simple definition of a system. The systems are classified as continuous time system and discrete time system based on signal processed by the system. This is the generalized block diagram of a system. So here system, that may be a continuous time and discrete time, and this is the input and this is the output. This input may be represented as excitations and output may be also known as by the response. If the inputs are continuous, that is x of t, and output is also continuous, that is y of t, then the system is known as continuous time system. And if input in the form of discrete signal, that is x of n, and output in the form of y of n, that is discrete, then the system is known as the discrete time system. Now this system mathematically is represented like this: y of t equal to capital T into x of t for continuous time system, and for discrete time system it is y of n equal to capital T into x of n. Okay, where y of t is nothing but the response or output, x of t is nothing but the excitation or input, and this t is nothing but the operator of the system. Okay, now these are the some of the types of the systems are: communication system, we are using regularly. Then it is control system, biomedical system, remote sensing system. So depending on applications, there are n number of systems are there. Okay. Now, system classification. This is the important part of this session. This continuous time system and discrete time systems are classified into different categories based on the properties of system. And what are these? Linear, non-linear, time variant, invariant, causal, non-causal, static, dynamic, stable, unstable, and invertible and non-invertible system. In theory paper as well as in online examination, one question is compulsory present there for 3 to 4 mark in theory paper, and online examination for 1 to 2 marks. Now first we will study the linear system and non-linear system. So a system whose output is proportional to the input is an example of linear system. A linear system satisfies the superposition principle. What is superposition? The superposition principle implies that it must satisfy scaling or homogeneity and additivity properties. Okay. The principle of superposition requires that the response of the system to a weighted sum of the input signal be equal to the corresponding weighted sum of the responses of that system to each of the individual input signal. And mathematically this can be expressed as, let us take the y1 of t equal to t into x1 of t, and y2 of t equal to t into x2 of t. The system is said to be linear if is t into a x1 of t plus b x2 of t, that is linear combination of two inputs, which is equal to a y1 of t plus b y2 of t, that is linear combination of the output. If this has been satisfied, then the given system is linear. If this system is not satisfied, then the given system is non-linear. Okay, so here a x1 of t plus b x2 of t is nothing but the linear combination of the input equal to the linear combination of the output. Static, next classification is the static and dynamic system. A system is called static if the output of the system at any instant t is a function of present input only. It is not a function of the past or and the future inputs. Otherwise, the system is said to be dynamic system. And the example of the static system is y of t equal to a into x of t. That is, present output is depends on only present input x of t. There is no delay, no advance, means no dynamic value is there. Okay. This is another example for static system. But here the accumulator is an example of dynamic system because it presents output is the addition of the past input and the present input. It needs memory to store the past value of the input. So this is known as a dynamic system. Simple definition, that is, a static system is also known as memoryless. It doesn't require any memory to store the things. And dynamic system is known as a system with memory. Just like example, resistor is a memoryless element, and inductor and capacitor is store the energy in the form of current or voltages. So it is known as dynamic elements. Next classification is the time invariant and time variant system. A system is called time invariant if its input output characteristics do not change with time. Otherwise, it is known as time variant system. So here let's take for continuous time and discrete time. Here continuous time y of t equal to t into x of t, and discrete time y of n equal to t into x of n. If this input is delayed by t minus td, then output is also delayed by t minus td, then the system is known as time invariant. If input is delayed by t minus td and output is not equal to y of t minus td, then the system is known as time variant system. Okay, time variant system. Remember, means in time invariant system, the shape of the signal doesn't changes. Okay, if the shape of the signal is changes, then the system is time variant. A similar relation is true in discrete time also. Next important term is causal and non-causal system. A system is said to be causal if the output of the system at any time t or n depends only on the present and or past input, but does not depends on future input, then the system is causal. Otherwise, system is non-causal. A system is said to be non-causal if the output of the system at any time t or n depends on the present and or past inputs and future inputs. So here future inputs has been added. Whenever future inputs are there, the system is non-causal system. Okay, means that the system is said to be causal in continuous time. Y of t equal to this t, this x of t and or x of t minus td, that is present input, delayed input or delayed output only. If system is said to be non-causal, then the output y of t is depends on present input, delayed input or and delayed output and future input and future input. This is known as non-causal system. Okay, and the last category is stable and unstable system. The system for which the output is bounded when the input is bounded, that is bounded input bounded output, BIBO, is known as stable system. Otherwise, system is said to be unstable. For the continuous time system, if system is said to be stable if integration of minus infinity to plus infinity x of t dt less than or equal to mx, where mx is less than infinity, and output is also, that is integration minus infinity to plus infinity y of t dt less than or equal to my, and where my is also less than infinity. When both are input is finite, output is finite, then the system is known as stable system, or we can say bounded input, bounded output. Bounded means finite value. Okay, and the same relation is true in discrete time domain. Fine. So this is the classifications of systems. In next session we will solve the examples on this, all this classification of system. Thank you.